Question number 20, paper 1. This question is from work per energy, and this question is based on work energy theorem. What work energy theorem say and what this question say? This question is saying that we have a body which is initially at point P. We are moving it on some elliptical shaped rail, and rail is frictionless, so there is no friction force. Everything is in vertical plane, so we have gravity force, and gravity force is acting on this block in the downward direction. During the motion of this particle from P on this rail towards Q, two forces are acting. One force is mg, which is acting in downward direction, and one force is F. This F is always acting parallel to the PQ, and the value of this force is constant, and it is 18 Newton. What it means? It means this force is constant force. Similarly, this mg force is also constant force. Okay, so two forces are acting on this body. What examiner is asking? Examiner is asking, when this body reach at point Q, what is the kinetic energy of this body? That is the question actually examiner is asking. So how will you solve it? See, we know two forces are acting, and examiner is asking kinetic energy. We will apply work energy theorem. What this theorem say? This theorem say all the forces which are acting on this body, if you sum up the work done of all the forces which are acting on this body, will equals to change in kinetic energy. This is actually the work energy theorem say. So how will you further solve it? You have to calculate work done of F and work done of mg. The work done by gravity plus work done by F is equals to change in kinetic energy. Initially, body doesn't have any kinetic energy, but when it reach at Q, it has some kinetic energy, and the examiner is asking actually that kinetic energy. So you will write K minus 0. Now what is the important thing now? You have to calculate work done by gravity, you have to calculate work done by F. How will you calculate work done by gravity? It's so simple. Force is acting in downward direction, and displacement of the particle or the body from P to Q in the direction of force is upward, that is 4 meter. But force is acting in downward direction. Because force is acting in downward direction and displacement in the direction of force is in upward direction. So the work done, by the formula mgh cos 180, work done will come negative. So it is mg. If you say this distance is h, if this distance according to you is h, so it is mgh with minus sign, because force and displacement is not in the same direction, it is in opposite direction. Plus. Now how will you calculate work done by force? Force is acting in this direction. If we can calculate displacement of this body along this direction, then direction of force and the displacement is in same direction. Therefore, to calculate work done, we just have to multiply force, displacement, and the angle between the force and the displacement. And you can see this angle between the force and the displacement is 0 degree, because force is parallel to PQ. Now what is this distance? This distance is 5 meter. And what is force? The value of force according to examiner is 18 Newton. So 18 into 5, an angle between the force and displacement is 0. Therefore cos 0 is equals to Ke. You know the value of m because examiner has given the value of m. And what is m? M is 1 kg. We know the h is 5 meter. After putting all the values, you will get kinetic energy, and that kinetic energy that you will get is 50 joule. Now what examiner is saying? Examiner is saying that kinetic energy is n into 10 joule. So if you compare, you will find n is 5. So what is the answer? Answer is 5. Thank you.